Want to take your welding simulation to the next level? Multipass welding is crucial for achieving high-quality welds, but optimizing parameters can be challenging. That's where Sysweld comes in. In many industries, multipass welding is essential for joining thick materials while minimizing defects like residual stress and distortion. However, understanding heat distribution, penetration depth, and cooling effect can be tricky. With this Sysweld simulation, you learn how to fine-tune your welding parameters for stronger, more efficient welds. But before we start, drop a comment about your welding project, let me know what you're working on, and I'll help you optimize your setup. As usual, we start with Visual Mesh. Okay, new file, and from file, save as. We create a new folder here, Multipass, then save. XY data, now we're looking at it from the side view, and from node by XYZ locate we can create the coordinates. So the coordinates are right over here. We can have a split screen to see that better. Okay, let's zoom out a little and let's have our XYZ. Here it's better to start with 0, 0. Then I can create 0 and 1, 0, 5, 27.69 and 5, 32.81, 5, 60.5 and 5, 60.5 and 1, 60.5 and 0. Now we have this one, then we need to create the root of weld, 30.5 and 1, 30 and 1, 30 and 0, and 30.5 and 0. Okay, now we have everything. We close this one. We have all the coordinates here. And from here to the 3.4 mesh, we start with the 4 point and we select our points here, these 4, by clicking on this one. Now we're going to have 9 for these two and 10 for this one, and it's better to have 2 right over here. So this one is 2, then we create the mesh and we hit OK. Now let's do it for the base metals. You can also press down the scroll button. This one we put 9 here, set to edge, and we set it to this one, and we need 25 for this one and this one. As this is only a 2D mesh, we don't need to create bias, but for a better optimized way, it's better to bias the mesh here. Create mesh, okay. Now let's do it for this one. You can also press the scroll button, so 2, 2 and 2 here, create mesh, okay. Now you can create this one right over here, set to edge, 25, 2, 2, create mesh, and okay. It's so crucial to start with this root pass, then creating the left one, otherwise you cannot create the left part, it would give you some error. So it'd be the same right over here. We can set the edges 25, 25, and by by clicking on this one, left click and hold, then we drag it down, we can have 9 elements here. Scroll button or this check button here. Then last but not least, this one, we create the elements, set to edge 25 to create mesh. Okay, boom, we have our mesh right here. I know meshing is really hard and most of the people have problem with it. If you have any questions about the meshing, just comment me down below. I will answer it as quick as possible. The next step would be to go to check. From here, coincident nodes, we check here. We have a couple of nodes coinciding. We click on coincide all, fuse all, apply. Now we check once more and we see we don't have any nodes coinciding. Apply. Now let's create the weld zones. This is going to be my root pass. So by right click and from tools, add to new collector, and I have to rename this collector. So from edit, we say this one is root pass. Okay, we click somewhere on the screen. Now we carefully selecting this one. This is going to be my second pass. So from here, tools, add to new collector, and we can rename it here. Let's say pass 1, and we select this one as the final pass. Tools, add to new collector, and rename it and name it pass 2. Okay, now we defined different passes we wanted to have. From 1D we go extract from 2D mesh to select the heat boundary. So we say extract 1D, we select this one, extract 1D. Now you see it shows us the boundaries, and we click on apply right into the part. This is the boundaries or heat environment boundaries we have. Okay, now we make sure that we don't have any coincide nodes. Now we check it for elements, fuse all, apply. Now we don't have any coincide nodes. Now it's time to create the clamping collectors. First, I press the skip button to make sure that no node is selected. I put it on node. I put this one, and the other side, this one, and this one. So we want to clamp both sides. And from tools, add to new collector, and we want to change the name. We say clamps, and OK. Now everything is done. We are done with the visual mesh. Then we need to save the file. So from here we click save, and the file is saved. Now it's time to go to the visual weld. Okay, now we need to open the file here from the Multipass. This is the document we're after, and I put it on XY to see it this way. From welding, we go to the trajectory. Here we need to create 3 trajectories. Let's create the first one. Here I'd like to go to this one and only have the root available here, and the path would be this one, and the reference can be this one, and we assume that element length is 10. Let's preview this one. By holding A or the scroll button, we can rotate it a little, and as we see here, this is okay, and we can apply this one. Now we uncheck all of them, and we only activate the pass one. The path would be here, and the reference can be here. Preview, we rotate it a little, and we double check and apply. So this is also created. This is J1, this is J2, and let's have the pass 2, and the path would be this one, and this one can be the reference. Preview, apply, and now we have all of them. Okay, we can close this one, and from welding it's time to go to the welding advisor. The name can be Multipass, and the working directory can be set as here, Multipass. Now we can go to the global parameter, to the cross-sectional. Now the materials. Okay, we can have the joints with filler, and we select S355, and from here we can select the joints, root 1, pass 1, and pass 2. By clicking on add, we have the filler materials, and from the components we can select part 1 and add. We have the material here, and we have the filler materials right over here. Okay, we can go to the next one. Here we have different things. For the first one, we're going to have the path. J1 is the root. We click on OK. So filler material would be filler root, and the welding group is also root. Okay, we have everything here. It's time to go to the weld pool. Let's make sure this one is joule per millimeter and this is millimeter per second, and we're having different welding parameters for all of them. I have a table here including everything, so let's do the split the screen once more and fill it out from here. Okay, the velocity is 4 and the initial time is 0, so the end time would be 5, and here the length would be 4, 2, and 1. We click somewhere in order to make it apply, and the energy must be 300. We click somewhere in order to see the decimals, and we can have add. Now if I zoom in and rotate, we see we have something right over here. Okay, it's time to create the second one. Now from here, weld line, we select the second one, changes everything accordingly, and from the filler we're going to have pass 1, welding group is also pass 1, and we click on OK. In the weld pool, there's something you should pay attention to. Here we have the interpass time or interpass temperature. Normally in the multipass welding we have different timings, so we have the time for the first pass to cool down and we have the second pass. The velocity in the first place is 3, but the initial time is 110 because time of the previous one was 5 and interpass time is 105, and with the starting time would be 110. So we have the end time 116.66, and the length should be 10, 5, and 2, and enter. But the energy is different and is 500 here. We click on enter and add. So if I click on this one, we see we have the gold dog. If you don't know about the gold dog, you can watch the video on top right over here to have an idea. Let's go to the third one. From here we select pass 3, pass, so this is the third pass, but the name is pass 2 because we have a root pass. Okay, the welding group is this one. Now it's time to change everything. The velocity this time is 4, but the time must be 100 plus 116, so I would say 116.67, and the final would be 125 because the whole time is 5 seconds, and the length would be 10, 4, and 3. If you don't know about this length, you can see the video on the top right. We discussed them in previous videos. The energy would be 400, and something that I should change about all of them is to put this efficiency on 0.63. I click on add. Now I have to go and change it. Sorry, I forgot. And we can change it right over here. As you see, the efficiency is different. Okay, we don't need this one. We open this one. Let's check the weld passes. So this is the first one, second one, and the third one. Okay, cool. We can go to the next one. So we define the cooling collectors. Okay, the collector was part 2. Let's see. Yeah, these are the boundaries that are in contact with the cooling environment. When we select this, it becomes yellow. We click on OK. Now we have this one, and the cooling would be here 0, and the end time must be 1000. Then we add. Okay, we have the cooling condition here, and this one we select clamps here. It must be rigid, all, and add. Here we select the clamps. We have them all here, and it should be the same as the cooling condition. And we click on add. We have everything right over here, and we're good to go to the next one. So we don't need step 7 and 8, and we can submit the job from here. Generate input data and click on solve. It asks us the file we have. We can have the multipass here. Now we check the files we want to have. So we basically have 3 passes, and we check them all and click on compute. Here we click on OK, and we wait. So when it turns green, it means it's finished. When it's blue, it means it is processing. As you see, we have a 2D model, and it should not take that long. Okay, the job is completed. Now we can go to the visual viewer to see the results. Okay, let's go to the visual viewer. We can say open file. From the results, we can have this one, the first one. Click on open. Okay, this is the part we have. Apparently there is no weld in the beginning. So from here we can have the temperature node. But before we proceed, so with these parameters we have, do you think that it can melt the roots or not? Just let me know in the comments down below. Okay, we double click on this one and we put the value of 1500 here because it's the melting temperature, and see how it goes. Yeah, as you see here, it melts down the root and it cools down to somewhere around like 100 degrees centigrade or even less to the room temperature. Then it goes to the second pass, and this is the third pass. Okay, the file I just showed you is not a complete file. It's better to go for this one. As you see, it has bigger size here, and if I click on this one, there's a problem with this software. I don't know why, but it doesn't show you element deletion, but it's more accurate. As you see, it starts with 2200. What I try to do is to have a plot. So here from file we can have important plot. From temperature node I can select this one, then we can go a little higher, just somewhere around, maybe it's better to put it on 1500 to see better. Yeah, I can select this node as well, then in the final one, let's say somewhere around here, and we can have a plot, and you see how the temperature changes in different passes. I go back to here once more, and from here we can see the phase info. This is the phase 1, which is indicated in the materials properties. If we go to the visual weld, and from here database material, we should find the material we're after, low alloyed carbon steel. Here in the generic info, you can see the phase 1 is ferrite, fictive phase, which is the filler material, martensite, bainite, and so on. Let's go back here. This is the ferrite. As you see, the material is ferritic, so that makes sense. This is the filler material. We should not see any filler material after the process. So this is the filler material in the beginning, and it go away. In the end of the process, we don't have any filler material left, which means that the welding parameters are selected wisely. Now what is also important is phase 6, which is austenite. Let's see whether we have the return austenite or remaining austenite after the process. As you see, there is not any, but during the process, because we hit the materials upper than the austenite formation area, we have austenite here and right over here and in the end of the process. And to see the final microstructure, we're looking for the final materials, which can be either martensite or bainite, phase 3 or 4. So let's see phase 3. It's in the end of the process. We don't have too much martensite. We have martensite here, but as we hit the material in the second pass, we don't have martensite after, so it might be phase 4. Yeah, this is the bainite. It means the process parameters were good, so we didn't have martensite, which is the brittle phase. Okay, this is the phase analysis. Now we can go and see this file, which is the stress-based analysis. Now I put this one on XY, and from here we can go to the stress, and we can see the element results, stress, and let's see the contour. As you see, these parts are clamped and this material wants to expand, but the clamp doesn't let it expand. And in the final process, we have the distortion here. If you want to know more about residual stresses, just watch the video on the top right to have a full comprehension of residual stresses. Here we see the residual stress is 591, which is pretty high, and it's more near the clamped region, just right over here. And we have a distortion right here in the weld. And that's it. If you find this helpful, hit the like button and subscribe for more welding simulation. Also, if you want to learn laser welding, click on the video on the screen.